Okay, against my better judgment, I'm going to try a small, live, and very, very basic Cucumber and Capybara demo. For this demo, I have made the world's simplest app. All it does is keep track of a list of students. In fact, it's so simple that it doesn't even have a user interface for adding students. Right now, the only thing it does is display the list of students. I put some students in the database so that you could see them, and you might recognize some of these names. So I'm going to do a scenario where I want to verify that when you list the students, they appear in alphabetical order. Now, I have not yet created step definitions. All I've done so far is I've written the scenario. This is my sort of nearly plain language description of what I want to have happen. So again, when I say list students in alphabetical order, I need to make that specific. One way to make that specific is to posit the existence of two students and verify that when I view the page, their names appear in the expected order. So for example, given student Tyler Lamb exists and student Armando Fox exists, when I visit the list of all students, so that's do something to the app, right? Visit the homepage that lists all students, then Armando Fox should appear before Tyler Lamb when I'm looking at that page. That's the post conditions, right? And this is the part where we get the output back and we're going to check something about the properties of that output. And remember that given, and, when, then, these are all the same method. I could have just as well written this. I could have used given everywhere, and it's no change. It doesn't make sense when you read it, because now you've got given, 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 and it sounds like they're all preconditions, and they're really not. But syntactically, just keep in mind they're all the same method. Okay, so I'm going to try to run Cucumber. Let's open a new tab here so that I have a prompt. And by default, by the way, where is this file? There's a directory called features that gets created in your app. Any file that contains one or more scenarios ends in .feature. And if you're using a clever editor, hopefully it can do syntax highlighting and stuff like that. Notice that the feature begins with the classic Connextra metadata. So the name of the user story, who is the stakeholder, what is their goal, and what is the task that corresponds to that goal. The other thing that's inside of the features directory is a directory for step definitions. And basically in there, you can put any files you want. It's conventional to call them whatever _ steps. Usually in a complicated app, there'll be sort of many different aspects of the app behavior, and each aspect of that behavior might have its own step definitions. You could put them in one file, but that's ugly and awful to maintain. So basically, it doesn't really matter which steps go into which file. Cucumber will just read all of them. And in terms of the features, I can run a specific feature if I want, or I can just say Cucumber with no arguments, and it will try to run every feature in order and log all the results. So for a really simple demo, we're going to try to get this one feature to work so that you can see the moving parts of steps and how they map to step defs, and how the step defs use Capybara to actually do the things that are in the user story. If I try to run this feature, and if I ignore the error message, the first thing I see is that everything comes out in yellow. And yellow is Cucumber's color for saying this step is not yet implemented. Or more specifically, what that means is I could not find a step definition to match this step. And since we don't have step definitions for anything, as soon as Cucumber hits the first unimplemented step, it kind of has to stop that story because there's no point in going on. So let's go ahead and implement the first one of these steps, which is given student Tyler Lamb exists. All right, well, let's go to the student steps file, which is currently empty. So now we need to write a step definition that, by the way, we want it to match both of these, right? Presumably, given that some student exists, we want to be able to reuse that step def. Now, I can tell you that the student model has just 3 attributes that matter. In fact, we could see them on our example list. There's the student ID number, which is sid_number, and then there's first name and last name. So any suggestions on what I might write for a step definition that would match, ideally, both of those lines, the Tyler Lamb and the Armando Fox line? Does it matter if I begin my step def with given, and, when, or then? It doesn't matter, but for clarity, because the purpose of this step probably is going to be for setting up preconditions, I will use given. So given, and now I begin my regular expression, student. If I capture a single string here, again, look at what the attributes. So in my model, it looks like the first name and the last name of the student are actually different attributes. So I could make life easier for myself if I just capture them separately. What about the student ID number? I mean, I could have said, given student Tyler Lamb exists and Tyler's student ID is whatever, but I didn't say that. Comment. Should I say it? Does it matter? I could have two students with the same name. In terms of this scenario, should I do something to deal with the student ID, or does it probably not matter much? It doesn't matter, right? Because this scenario is not about that. What is this scenario about? It's just about whether two students whose names are different appear in alphabetical order. Now, I think there's a great corner case, which is, well, what if you have two students with the same name and different IDs? What does it matter what order you display them in? But that would be a separate story, right? That might be another scenario that I could put in this file later saying scenario, two students with same name are listed in order of student ID, let's say, right? So this is actually a really good illustration of, even though I have a pretty specific story, there's always a corner case or two that you hadn't thought of. So there will be typically multiple scenarios that are associated with that feature. But for now, let's concentrate on finishing up our simple scenario. So now, by the way, this is going to hold me to having exactly one space, right? If I write this step definition, if I proceed as I'm going, but up here, if I inserted extra spaces by accident, things would break. However, I don't care about that, right? If I were writing some code that would in some sense be user-facing, I would care. I wouldn't want the user to get a stupid error message because they put two spaces where only one was expected, or because they accidentally put a leading or a trailing space. For user-facing code, you absolutely should care about that. But this is not user-facing code. This is test code. This is code for us, the developers. So I could be a little more flexible and say something like that, one or more spaces, but whatever. It'll be fine. It'll be fine. Okay, so given student, and now I'm going to capture two strings. And remember that for every capture group in my regular expression, each one of those is going to be bound to an argument in the code block. So it seems reasonable to assume that I'm going to be capturing the first and last name. What could I do here? Just create it. So let's do... And by the way, I'm going to use create bang. Again, if this were user-facing code, I would almost never use create bang, because remember that create bang throws an exception if something goes wrong. But this is test code. This is for us, the developers. We want to know if something goes wrong in a test. So this is a good place to use the dangerous methods. Okay, so we're going to say first name is that, last name is that. We need an ID though. But I'll just make one up. We'll just give them a random ID, right? By the way, this is a very common thing in scenarios. In this scenario, we don't care what the student's ID is because that's not what the scenario is about. However, it may well be the case that in order to create a student, they have to have an ID or the create would fail, right? This is a very common thing. And when we talk more about fixtures and factories, there's ways that you can sort of automate a lot of this away. So that basically, if you just say, look, I just need a student, do whatever you have to do to make the student legal, make up a fake ID number, give them a nationality. I don't care. Just create for me a student. There's a facility called factories that we're going to use to do that. For this simple example, though, we'll just go ahead and do it the hard way. Okay, so we've created the student. By the way, you might ask, if I run this cucumber scenario on my computer multiple times, am I going to end up creating multiple Tylers and multiple Armandos? And the answer is no, because every single cucumber scenario, even scenarios that are in the same file, and this is also going to be true when we talk about unit tests and functional tests, every one of them starts out with an absolutely clean slate. The world has never been populated before. It's the first time I'm seeing the app. There are no cookies. The database is empty. The database is always empty at the beginning of every test. So anything that you expect to have in the database in order to do a test, your test has to put it there. And remember when we talked about Rails defines 3 environments: production, development, tests. and each one of those environments has its own database. The way to think of this is the test database gets blown away for every single test case you run. So if you run 1,000 test cases and as part of your entire suite, the database will be completely blown away 1,000 times. And every test that expects anything at all to be there has to put that stuff there itself. This is one of the things that makes tests repeatable and independent of each other. Okay, so with that in mind, we've created 2 students. Let's try running Cucumber again. Woohoo! Look, I got 2 green things. Green is why the tool is called Cucumber. Cucumbers are green. Green is good. Green means that that step passed. Now, passing is a little weird because all we did is create a student. We didn't really test anything. Like, we know create should work. It's just active record. But nonetheless, we've got 2 steps of our scenario. So let's go on to the 3rd step, which is when I visit the list of all students. And again, for clarity, I will use when, even though it doesn't actually matter. I visit the list of all students. There's no particular place for a regular expression here because it's just visiting the list of all students. Like there's no variation in that. So I still have to say do, but now there's no arguments because there was nothing to capture as part of a regular expression. What would I do to implement the behavior of visiting the list of all students? And here's a hint. Capybara has a method called visit, which will generate an HTTP request to the server with whatever URI I choose. What goes in the quotes? Right. I could also, by the way, I can take advantage of the helpers that Rails defines if I want, right? Which again, using the helper means that I've now decoupled the test from the implementation of route mapping. Okay. Woohoo! 3 things are now passing. Now, remember, here, when I showed my app running in development mode, and I said I put some students in the database, remember that when we run these Cucumber tests, we're not using the development database. We're using the test database, which starts empty. So out of an abundance of caution, when I run these 2 lines that create the students, I want to actually see what the app sees. So I'm going to temporarily stick something in here. Is safe? Is that right? This is another cool Capybara-ism. I'll run this again. But now, as a result of my putting save page in that step definition, if I look in the temp directory of my app, Capybara has now created a subdirectory, and it's got this unwieldy long file name in it, blah, 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 blah.html. So let's take a look at what's in that file. Open. Aha. I'm going to make this larger so you can see it. So this is what Capybara sees as of that moment in the step def. So after I have visited students path, presumably the result of doing that is the browser got back a glob of HTML. Here is that glob of HTML. And you can immediately see that we're setting ourselves up for failure because apparently the students are not being listed in alphabetical order. It looks like they're being listed in the order in which they were created. So we can verify by saying, well, let's see, how would we implement then Armando Fox should appear before Tyler Lamb? Well, I happen to have some code that I prepared, which I can walk you through that does this. Make this a little bit wider. So basically my game plan here is I create a regular expression that matches the first and last name of a student, followed by anything, followed by the first and last name of the other student, right? So if I'm basically, this is going to match Armando Fox for the first 2, Tyler Lamb for the second 2, basically building a regex that will match Armando anything, Fox anything, Tyler anything, Lamb anything. And if I take just the text on the page without considering HTML tags or anything else, and I sort of just splat out that text as a long string, the regular expression I constructed should match that string if the students are being displayed in that order. Does that make sense? Okay, so now you can see why we're sort of setting ourselves up for failure, by the way. And then how do I actually check the page? Well, one of the sort of important objects in Capybara is this object called the page. There's a lot of things you can do on a page. And when we continue a more advanced demo next time, I'm going to show you how to sort of dig into the page to find a particular element or a particular CSS class or ID. But for now, one of the things you can do with a page is ask for page.text, which is take out all the HTML stuff and just keep all of the text and hand me back one long string. And that's pretty convenient because in this case, that's exactly what we want. We're just going to grab that one long string and we're going to match. We can take out the save page as well, I suppose, because we no longer, now that we know what it's seeing, we can take that out. And if we run it again, whoops, no. If we run Cucumber again, okay, so we've got our 3 passing steps like before, but now we have a red step, which means the step ran but failed. It ran, but it did not do what we expected. And in particular, we said expect page.text to match the regular expression. And it said expected. And here is basically, this is all of the text extracted from the page without any of the HTML tags or other markup. And it said, Capybara is saying, it expected this whole string to match my regular expression, but it did not. Okay, so predictably it failed. And in this case, as I'm sure you know, the simple fix is to go into the student's controller. And instead of just listing student.all, we're going to order the students by last name. And we can verify that if I do that, that makes it pass. And if I want to be absolutely sure because I don't really trust it, I can go back to the step definition and one more time I can put save page so that not only will the test run, but we can also inspect the results. And now there's 2 long files, but we're going to open the more recently created one, which, by the way, you can just blow the temp directory away anytime you want, but there, right? By modifying the controller method, we got the result we wanted. So if I look at the takeaways from this demo, behavior-driven design means that at the level of the scenario, we're not saying how something is done. We're only saying what we want done. The step definitions are where the how comes in, right? Given a student exists, there's going to be a step def that actually makes that be the case by playing around with the app. We use regular expression matching so that the steps are reusable. And when I say we're defining a domain language, a step definition like given student so-and-so exists makes sense for this app. But if you looked at the Cucumber scenarios for a bank account app, you probably would not see anything like that. So the vocabulary that you're defining as you write your steps and write your scenarios is like a little domain language for your app. Next time, we'll talk about scoping to specific elements, which means we want to make sure that text occurs, but we want to only look at a certain part of a page to make sure we don't accidentally capture the text occurring somewhere that we don't care about it. In the meantime, I strongly recommend that you start sort of browsing the Cucumber documentation at cukes.info, a very cute site name. And we will continue in the next module with slightly more sophisticated scenarios and sort of power tools for Cucumber and Capybara. Have fun.